In the waning days of August 1859, British astronomer Richard Carrington observed a peculiar white flash erupting from a sunspot on the solar surface, something no human had ever recorded before. Within hours, the Earth was struck by a geomagnetic storm of unprecedented magnitude. Telegraph systems across North America and Europe sparked and burned. Operators suffered electric shocks, papers caught fire, and in some locations, messages could be transmitted without any power source, only the storm's natural current. But the most surreal consequence appeared in the sky. Auroras painted the night in crimson and green, visible as far south as Cuba and Jamaica. In the American Rockies, miners reportedly woke at 2 in the morning, mistaking the glow for sunrise. Ships at sea thought cities had caught fire. Yet for all its drama, the world in 1859 was largely analog. Telegraph wires were the cutting edge. If the Carrington event struck today, with satellites in orbit, planes in flight, power grids stretching across continents, it would be catastrophic. Infrastructure would collapse. Internet services would halt. Financial systems could crumble in hours. What Carrington saw through his telescope was not just a solar flare, it was a warning blast from the sun itself. And it was only the beginning, because in the decades that followed, the sun reminded us again and again, it's not done with us yet. In May of 1921, a lesser-known yet powerful solar storm swept across Earth, sparking chaos in one of the world's busiest cities, New York. Early in the morning, a burst of geomagnetic activity triggered a series of electrical fires at the New York Central Railroad's signal and switching system. Telegraph lines overheated, railway controls malfunctioned, and operators stood helpless as fires ignited inside relay stations. Meanwhile, auroras flared overhead, visible far beyond their usual northern range, dazzling and disorienting onlookers unfamiliar with the phenomenon. This wasn't an isolated rural incident. It was a direct hit on a city that never sleeps. An attack not by war or sabotage, but by the sun itself. Engineers documented unexplained voltage surges in electrical grids, while news reports vaguely mentioned a magnetic storm. Despite clear evidence linking the disturbances to solar activity, no coordinated effort was made to shield urban infrastructure. It was as if the Carrington event had been forgotten, but this new storm proved that major cities weren't immune. And unlike in 1859, society now relied on electricity for trains, commerce, and communications. Still, warnings went unheeded, but the sun was only beginning to flex its muscles, and the next time, it would plunge millions into sudden darkness. On March 13, 1989, the lights went out across the Canadian province of Quebec. At exactly 2:44 in the morning, after a series of intense solar eruptions, a geomagnetic surge overwhelmed Hydro-Quebec's massive power grid. In just 90 seconds, the entire system collapsed. Over 6 million people were left without electricity. Schools closed, businesses halted, the metro stopped running. What caused this blackout wasn't a storm on Earth, but on the sun. A coronal mass ejection traveling at nearly 1 million miles per hour slammed into Earth's magnetic field, generating currents in power lines that acted like massive antennas. Transformers overloaded, systems failed. The blackout lasted 9 hours. In some regions, even longer. Scientists later confirmed that had the storm struck the US Northeast instead, the impact could have cascaded into a continental crisis. The event cost Canada millions of dollars in damages and lost productivity. It was a stark wake-up call, but one still largely ignored outside scientific circles. And yet, while the power grid failed above ground, another threat was silently brewing deep beneath the ocean's surface. Stretching across oceans, buried in darkness and salt, lie thousands of undersea cables, delivering more than 95% of global internet traffic. While their optical cores are safe from electromagnetic interference, the electronic components that amplify and control the signals are dangerously vulnerable. During major solar storms, long conductive cables act like antennas, channeling geomagnetically induced currents toward vulnerable coastal stations. This threat became clear during the 1989 Quebec Blackout, when transatlantic cable systems experienced unexplained voltage spikes and partial signal loss. Experts warned that in a storm comparable to the Carrington event, dozens of major data routes could simultaneously fail. With financial markets relying on millisecond communications, the result could be catastrophic. Frozen transactions, lost records, global economic panic. Modern infrastructure is interconnected. A single cable failure is manageable, but a global pattern of outages would ripple through every continent, and the scariest part, we have no real-time defense. Still, some of the strangest consequences of solar storms have nothing to do with electricity at all, and everything to do with unintended explosions. In August of 1972, during a lull in the Vietnam War, US Navy officials were stunned by a string of bizarre detonations. Dozens of underwater mines planted by American forces near Haiphong Harbor exploded spontaneously, without ships, contact, or human trigger. Investigations initially found no cause, but later, declassified documents revealed the truth. An intense solar storm had hit Earth that same week, peaking just as the mines began detonating. The geomagnetic surge was so strong, it triggered the magnetic sensors in the mines, mistaking the distortion for enemy ships. That same storm also jammed high-frequency radio communications, disrupted satellite data, and confused navigational systems across multiple continents. It was one of the fastest and most violent solar storms ever recorded. And unlike the Quebec Blackout or the Carrington event, this incident involved real weaponry, real consequences, and potentially deadly outcomes. The sun had, quite literally, ignited the battlefield. But its influence wasn't limited to modern wars. During the Second World War, solar fury struck again, this time across enemy lines. In September of 1941, with the world engulfed in war, Allied and Axis forces alike experienced a bizarre twist in the battlefield's invisible front. Sudden, global communication failures. For hours, radio operators struggled to make contact. Shortwave signals dropped out. Radar systems flickered. Unknown at the time, this disruption was caused not by enemy action, but by an intense solar storm that struck Earth's magnetic field without warning. Reports from Britain to Germany mentioned erratic compass readings and loss of navigational accuracy. In the chaos of war, few had time to trace these anomalies to space. Yet post-war analysis confirmed that this geomagnetic event was one of the strongest of the early 20th century, and it likely impacted naval and air operations on both sides. Unlike power grid failures, these effects were invisible but critical, guiding bombers, submarines, and troop movements. The storm revealed how cosmic forces could quietly shape the course of history, and even in peacetime, the interference continued, especially for the first real-time communication system the world had come to depend on, the telegraph. Long before smartphones and satellites, telegraph lines were the arteries of global communication. But during geomagnetic storms, they became dangerous conductors of natural electricity. In multiple historical incidents, including Carrington, New York in 1921, and even minor storms in the 20th century, telegraph wires sparked violently, shocking operators and setting paper ablaze. In some instances, the wires themselves emitted enough current to operate without batteries. The Earth's changing magnetic field was generating voltage across vast distances of copper wire, effectively weaponizing the technology. Messages became garbled or unreadable. Operators feared for their lives. The public, unaware of the cause, viewed these failures as technical flukes or even omens. Telegraph companies began quietly tracking solar activity, hoping to predict the next surge. They couldn't. The sun's temper remained a mystery, but what telegraph lines hinted at, power grids and infrastructure would later confirm. Long conductive systems were magnets for solar fury, including some buried deep in the ocean or even deeper underground. Beyond wires and cables, geomagnetic storms also impact something far less obvious: pipelines. Metal pipelines, especially those that stretch across continents, can conduct geomagnetically induced currents just like power lines. These currents alter the electric field surrounding the pipes, disrupting corrosion protection systems and accelerating metal decay. In the 1980s and 90s, engineers began to observe unexpected spikes in pipeline voltages during solar storms. Some maintenance teams reported abnormal wear and signs of localized corrosion after intense solar events. For gas and oil companies, this posed a silent, long-term risk. It wasn't dramatic like a blackout, but it was costly, dangerous, and largely misunderstood. Experts have since warned that without proper monitoring, a major solar storm could lead to multiple simultaneous pipeline failures. Leaks, explosions, contamination, infrastructure that was meant to be robust could crumble under the invisible pressure of solar interference. And while pipelines suffer in silence, satellites above Earth face a more immediate threat, one they can't escape. Orbiting hundreds of miles above Earth, Satellites serve as the nervous system of our modern world. They guide planes, track weather, deliver GPS, and enable global communication. But during strong solar storms, they become vulnerable targets. Charged particles from the sun penetrate Earth's magnetic shield and slam into satellites, damaging sensors, corrupting data, and occasionally knocking entire systems offline. During the March 1989 storm, several satellites reported signal loss and attitude control problems. In more recent events, GPS accuracy has dropped by dozens of feet, disrupting agriculture, shipping, and military navigation. Some storms cause satellite drag to increase, forcing operators to adjust orbits manually or risk losing control entirely. And as more satellites crowd low Earth orbit, including thousands of commercial microsatellites, the margin for error is shrinking fast. But even spacecraft designed to withstand the void of space aren't immune. One of NASA's own shuttles once faced solar fury firsthand. In March of 1989, just days before the Quebec Blackout, NASA launched Space Shuttle Discovery on mission STS-29. During the mission, unexpected anomalies began appearing in the spacecraft's onboard systems. Sensor data glitched, communications wavered. NASA engineers quickly linked these issues to an ongoing geomagnetic storm triggered by a recent coronal mass ejection. While the shuttle remained operational and returned safely, it marked one of the first times a crewed spacecraft encountered space weather effects in real time. The incident spurred new discussions within NASA about the need for better solar monitoring and pre-launch risk assessments. Since then, space agencies have built systems to track solar activity, but even today, predictions remain imprecise. A wrong calculation could mean a catastrophic failure during launch, docking, or re-entry. And as technology becomes ever more reliant on space-based infrastructure, the cost of ignoring the sun continues to rise. Modern scientists warn that another storm like the Carrington event is not just possible, it's inevitable. The sun operates on roughly 11-year activity cycles, and while we've avoided a direct hit since the late 19th century, solar physics suggests we're overdue. In July of 2012, a massive coronal mass ejection narrowly missed Earth by just 9 days. If it had struck, NASA estimates it could have caused trillions of dollars in damage, crippled power grids, and left entire regions without electricity for months. Banks, hospitals, water systems, all vulnerable. Satellite constellations could have been degraded or destroyed. GPS gone, communications severed. And unlike in the past, global infrastructure today is digital, interconnected, and critically dependent on timing and power. Despite the risk, most countries remain unprepared for such an event. Experts call it a disaster waiting to happen. But it's not just technology that increases the danger. Human error, politics, and institutional blindness have also made us more vulnerable than ever before. Throughout history, solar storms have rarely been recognized for what they are. In many incidents, telegraph fires, exploding mines, satellite failures, investigators first searched for mechanical flaws, sabotage, or software bugs. Only later, sometimes years afterward, were the true solar causes discovered. Part of the problem lies in institutional inertia. Governments don't prioritize space weather the way they do earthquakes or hurricanes. Many leaders see it as abstract, unlikely, or irrelevant. This mindset leaves critical infrastructure unprotected. In some cases, officials actively ignored solar warnings, choosing not to shut down systems for fear of financial loss. The result? Near misses, silent failures, and close calls that never made the news. Even today, solar observatories struggle for funding. Public awareness is low. Most people don't know the difference between a solar flare and a sunspot, let alone how either could destroy their power grid. And yet, when auroras light the sky, we still stare up in awe, forgetting that beauty and danger can come from the same source. There's something hypnotic about the northern lights. Curtains of green, red, and purple shimmering silently above frozen forests and empty tundra. For centuries, humans have told stories of spirits, omens, and cosmic signs dancing across the sky. But beneath the wonder lies a hidden menace. The same solar energy that creates auroras also distorts Earth's magnetic field, overcharges wires, and knocks satellites off balance. In truth, the northern lights are only the visible edge of something far more powerful. And while most storms pass without major damage, it takes just one perfect storm to change everything. The next time the auroras stretch down to unfamiliar latitudes, lighting up cities that rarely see them, it may not just be a spectacle, it may be a warning, a signal that something bigger is unfolding above us. Because while the northern lights are breathtaking, their true nature is not just beauty, it's power, untamed, ancient, and waiting.